Hello and welcome to this special episode of the CORDIScovery podcast. Today we're looking at the transition to a circular economy and how this could pave the way for a cleaner and more competitive Europe. Unlike the traditional linear model of take, make and dispose, the circular approach focuses on reducing waste, reusing resources and designing products and systems that can last. I'm joined today by representatives of 3 projects that have received funding from the EU's Horizon Europe programme. These projects show how research and innovation are helping Europe lead the way in making circularity a reality. So welcome, first of all, to Mattia Comotto. Mattia is a chemist by training. He's a project manager of Effective and head of circular economy and sustainability at Aquafil Group. Ivar Palk from Estonia is responsible for sales at RAIKU Packaging, which produces natural compostable packaging material to substitute bubble wrap and single-use plastics. And finally, Esthèle Goure, who is project acquisition coordinator at Biobase Europe pilot plant in Ghent. She was the coordinator of the Waste to Funk project, and she's a biotechnology engineer by training. So welcome, Mattia, Ivar and Esthèle.
Good morning. Good
morning.
Mattia, if I could start with you, your project aims to show how bio-based ingredients can be used in the manufacturing of products across a wide range of sectors, from construction to cars, from packaging to clothing. Where do those bio-based ingredients come from, and why is it important?
Well, first of all, thank you for the invitation and for the question. The source of our bio-based ingredient that we have demonstrated within Project Effective basically comes from sugars. Once you reach a certain quality that is suitable for the conversion processes, the source of sugars no longer matters. It can be sugar beets, it can be sugarcane, starch, even sugar that are produced from agricultural waste, for example. So quality is of key importance. When you reach it, it's only a matter of availability. For industrial production, it's a matter, of course, of cost. And then, of course, it's a matter of sustainability. The environmental impact that is associated to the production of sugar that needs to be taken into account when you try to develop a new and more sustainable solution.
And what would have happened to the different sources of this sugar if you hadn't been able to find ways of reusing it?
Well, conventional source of sugar like sugar beets or sugar cane are traditionally used by the food industry. We have worked with a very big and important firm producing sugar in Europe. And what they told us is basically that until 2016, there were quotas on sugar production. After 2016, sugar quotas were removed. So, of course,
the production increased.
Increased, but at the same time, the market demand decreased. For example, there are plenty of sugar-free solution in the shops. So they had a kind of surplus of production that they are trying to valorize more than keeping them on the stock. So that's a possibility of using that share of sugar that is not valorized right now. For what concern agricultural waste, for example, that basically they were not used.
Not used at all.
They can be used, for example, in biodigestion process to produce biogas, biomethane, but not really high value application.
And once you've sourced the sugar and managed to extract it, how does it then find its way into these various products that you're working on? As I said, from construction to cars, packaging, clothing, carpets, if I understand correctly. How does that work?
Well, there are many conversion processes. First, biotechnological processes with tiny microorganisms that eat sugar and produce target molecules that we use to produce, let's say, different families of plastic. Within the project, we target 2 main families that are polyamides and polyester, widely used polymers at global level. If you think about polyester plastic bottles, polyamides like woman tights or raincoats, for example. So there are different biotechnological and then chemical processes that are run to convert sugar into the final plastic that is then converted into yarns, filament, films, and potentially any application that we want to target.
Okay. And if I'm correct, your project is now finished, right?
Correct.
So might some of our listeners be wearing products or walking across carpets or using items that have been made with these different kinds of plastics?
We are not there yet because we successfully demonstrated the production of prototypes, like you mentioned, carpets, swimsuit, bike pants. But we are not at commercial scale yet. Mm-hmm. We are finalizing the fine-tuning of the technology, the ambition of achieving the targets and the KPI that we set. And once we manage to do that, the very last mile will be to set up an industrial scale facility able to produce large volume of this biomaterial that then can be used in the products that you mentioned and the consumers can experience and feel them.
Okay. Maybe let's come back to that in the general discussion because we're talking a lot about startups and scale-ups in Europe at the moment. So it would be interesting to hear, your experience and the other guests, what could help you take it to the next stage. But now let's turn to Ivar, representing the RAIKU project here. Your project aims to optimize the use of wood as a natural biodegradable material for packaging. It sounds quite obvious, but can you explain to us why it's preferable to use wood rather than plastics for packaging?
Mm-hmm. With the plastics, it's of course the carbon footprint that will be like a big difference in the production processes, but also, as there's like more e-commerce and more shipping like products, on the other side, like 30% of the Europeans don't recycle. So we need like a material, that natural material that can recycle itself. That's like the major things.
Right. And would I be correct in thinking that it's less resource intensive to produce packaging in terms of water and energy and so on using wood rather than plastics?
Yeah, of course. There's like 2 to 3 times the difference. And also, for example, like some people think that, okay, maybe the paper is like more environment friendly, but actually, for example, compared to paper, the whole process takes like, 10 to 20 hours for us to make the springs, that the packaging material, it takes like 30 seconds.
Okay.
So it takes like lots of less energy, like more than 3,000 times less water, and also like 50 times less energy.
I see. And how do you make sure that you source the wood in a sustainable way, avoiding deforestation and so on?
Yes. So first of all, our supplier gets the food from sustainably managed forests, and also we get kind of the offcuts of the supplier's products, so which they can't sell anymore because they don't fit their demand. So we get it from that side, and also the wood that we use is kind of is alder wood, which is not really popularly used in Europe. Mostly just burnt to get energy.
I see.
And the way we make the products is so effective that from 1 cubic meter of wood, we get like 20 cubic meters of our packaging material. So it's like making popcorn, basically.
Okay. And maybe I'll ask you a similar question to the one I asked Mattia. I mean, are the solutions you're working on commercially available currently?
Yeah.
Okay.
We're on the market, and we have like over 100 customers from 15 different countries.
Okay, so you've got a busy job doing sales through them.
For sure.
Very good. Okay, let me turn to Esthèle. So the Waste to Funk project. So you work for the Biobase Europe pilot plant here in Belgium in Ghent, which is a service provider for bio-based products and processes. And you're in the business of converting agricultural and industrial food waste into raw materials that can be used to make consumer products. The Waste to Funk project demonstrated the production of biosurfactants and lactic acid from food waste from agriculture, the food industry, supermarkets and restaurants. Perhaps could you tell us what are biosurfactants and lactic acid and why are they useful for producing these kind of products?
That's a long question that I could answer for a lot of hours.
The short answer, yeah.
Indeed. So maybe to tackle this question, two things. The project is building around food waste and the lactic acid and the biosurfactant. Indeed. Why? It's because the lactic acid and the biosurfactant are everywhere in your world. I hope that you brush your teeth this morning because the toothpaste is containing surfactant and can help you do the foamy stuff in your mouth, for instance. So surfactants are everywhere in the world. And basically, today, you could find it in customer products like laundry, like cleaning product, but also paint, ink when you're writing this nice wave when you're like having the paint on the paper. That's surfactants. Unfortunately, there is a lot of fossil-based surfactants that are starting to be banned. But to be honest, it's the majority of the market for now. And biosurfactants are already starting to be commercialized via biotechnological route, like you mentioned. But those ones are built upon a value chain of first-generation sugar, meaning that the sustainability behind that is quite challenging. So on that, the Waste to Funk was built about food waste to make this sustainability a bit better and also to provide those new molecules to the market that address a lot of needs. And for the lactic acid, it's a more common chemical. You have it in different applications, but you can go to PLA, so a polymer, for instance. But nothing yet on the market from food waste. So that's why the innovation of this project was really building around food waste to make it more sustainable and the two molecules that are addressing needs on the consumer market.
Right. From the consumer perspective, as you say, we all brush our teeth in the morning. I imagine some people might be a bit nervous about the idea of brushing their teeth with something that has been made partly using food or industrial waste. How do you go about reassuring consumers that all of this is safe and healthy?
It's a good question. In the project, so European project, there is a lot of partners, right? We are only one, scale-up facility, so really focus on the technical part. But overall in the project, there were also the end user, so Ecover. And Ecover did a lot of consumer studies, also tried out different marketing, interaction to make sure that the messaging was clear and made sense. And there were a lot of drawbacks to a circularity because people were not really understanding it. And that's why the prototype that we produced was focusing on waste is not waste if it's not wasted. And that messaging was a bit strong in comparison of all the other type of messaging. And I think that's some nice information that the technology owner, so the Amphstar for biosurfactant and WW for the lactic acid, learn, and now they are working on how to commercialize the product to make sense to the consumer.
Right.
But it really depends on the market because, for instance, surfactant, you could find it in agrochemicals when you spray things on the crops. Up to your toothpaste, but up to the paint. So the market is different, so the messaging should be different as well.
I see. And your Waste to Funk project has also finished now, like Mattia's project. If I understand correctly, I mean, you were at the stage of developing prototypes, but not yet making these products commercially available. But I think there were two spin-off projects, which presumably are taking you a little bit further on the journey. Can you say a little bit about that?
Yeah, indeed. So Biobased Zero pilot plant was the coordinator of Waste to Funk. And in this project, as I mentioned, W and Amphystar were two startups that were building up their technology from TRL 5 to TRL 7.
Okay.
And
maybe for our listeners, we should just explain the TRLs are technology readiness levels.
It's basically that they had already their concept proven at enough production scale, let's say. But the TRL 7 is really to have hundreds of kilos to address formulation and make sure that the end user, like Ecover, but also Procter & Gamble, Unilever, any kind of end user could use their product. So it's not there at the large scale production, but it's there that the technology is de-risked to make investment to build their own factory. That will be the next step. And basically, I'm answering the question by saying that the Waste to Funk project ended last year, end November. And throughout this year, Amphystar got a lot of funding, even an EIC accelerator.
Oh, okay.
W also got an EIC accelerator the year before. And along that, they had a lot of investment and different grants. So they are in the shape of building their capacity to produce for the market. And indeed, in parallel, two European projects got funded. One where I'm still the coordinator for the biosurfactant line, that is called SurfSup, where we developed a lot of different biosurfactant for the market, where Comotto, Unilever, and Ecover will also try it out. And for W, they are building their flagship. So it's CBEGU also funding, and it's building their own plant in Amsterdam. So that's quite cool.
Okay, very interesting. Can I just return to you, Mattia, because we finished by sort of asking this question about what it would take to bring your project to the next stage. Having listened to Esthèle's experience, you mentioned the EIC Accelerator Grant, for example, and the spin-off projects. What are your plans?
That's a great question. Certainly, the plan is to finalize the development program. As I said, we have set a few years ago some targets, some KPIs for production, yields, quality, etc., that we need to achieve before starting to take the last mile. Once we reach those targets, the work that we have ahead is to set up a commercial facility. That sounds like a very simple task, but actually it is not. Because this task requires significant investment. And let's say the market scenario right now maybe is not the best.
Why is that?
Well, the price of energy, especially in Europe, is quite high, and energy is a significant cost in industrial facilities. Certainly one step that we need to explore a little bit more in details is the availability of feedstock. So where can we source sugars at a reasonable price with a good environmental footprint? So there are different areas that we need to deep dive a little bit more in order to have a clearer picture on where this industrial facility might be built and can produce a large volume of the product that we are currently developing.
Okay. And do you think you can do that in Europe?
That's certainly an option. We have run our development program in Europe, so it might be a logic next step to follow up this project with an industrial facility in Europe.
Yeah.
Again, it's an option. We are exploring it. Certainly, it would be a fantastic solution, especially for Aquafil, that is the company I work for, because we have a unique recycling facility in Slovenia, in the city of Ljubljana.
I see.
Where we chemically recycle nylon 6 waste, both pre and post consumer. So it would be a nice story of sustainability, having a plant in Europe that is able to recycle waste, and at the same time having a different plant that is able to produce the same polymer, the same type of plastic from plant-based raw material.
Okay. I'd like to explore another issue with the three of you, which is the potential of circular solutions to bring positive benefits for the environment, but also to have a positive economic effect. And Esthèle, if I'm not mistaken, your bio-based Europe pilot plant employs around 160 people. So clearly there's been job creation and economic activity there. So what is the potential in your view?
It's a broad question again, but for the bio-based Europe pilot plant, so we are pilot and demo infrastructure in Europe. So we do help startups, SMEs, and corporations to scale up their processes, biotech processes, up to the commercial level that they want, to make sure that they either go to a CMO or build their own plant. So the 160 employees is quite consequent, but it's not enough to make sure that all the technologies are going to market. But the creation of employment and so on, we see it from the startups, for instance, and the SMEs that are growing, like Amphastar. When we ended the project, there were 5, now then 25. So those numbers are quite consequent, and same for WW. Building their own plants means that they need to employ operators, technicians, and so on and so forth. So that's really concrete, and that's thanks to the investment in the European projects, but also the technology readiness that is moving on. So that's quite nice.
Okay. And Ivar, you mentioned that RAIKU's products are commercially available. Can you give us an idea of what kind of workforce you have, what kind of economic dividends your business brings in?
Yeah, so compared to others, we have like a pretty small group. We have like 20 people from there, like 10 of us are engineers and other people. So yeah, we're still young in that sense.
And how young is the company?
The idea started like 4 years ago.
Okay, so quite recent.
Yeah, so yeah, like first 3 years, as we started from the scratch, there wasn't any such technology before. It took like still a lot of time to figure it out, like how to make it.
Okay, and are there plans to bring the business to a next level?
Yeah, we're scaling up right now. So we have like big demand, but we also need to fulfill the demand as well. So we're increasing the productions, and also in the next couple of years, we're planning to expand to, for example, to France as well, where it's like a big luxury market.
Yeah. And what would be the biggest challenge there? Is it finding infrastructure or capital or the right talent to help grow your business?
Yes, just increasing the production. Getting the new machinery. Because otherwise the machinery is pretty modular. We can scale up on that. It's unique in that way. But yeah, just going up.
Okay. One last question for the three of you. If you could just summarize in one sentence how you would encourage people, what kind of positive message you would send out to people out there to encourage them to consider circular solutions, what would it be in a nutshell? Mattia, would you care to go first?
Yeah, I start from what Esthèle just said. Waste is not waste until it is wasted. So certainly one topic each of us could work on is on the regulation side, because we should avoid that product end up as a waste, but it can be used as new resources or secondary raw material for the production of circular product. That's certainly one key topic.
Thank you very much. Esthèle, do you have something to add?
Yeah, I will stay positive, and that I can assure that there is growth behind circularity, and that there is employment, and then there is excitement behind the technology, because indeed we are not making like first with AI or robots, but the technology is quite innovative, quite strong, and that I think it's worth digging a bit more and investing a bit more indeed.
Thanks a lot, Esthèle. And Ivar?
I think we shouldn't be afraid of trying out new products and things. If you're a consumer or a decision maker in a company, don't be afraid to try it out and give it a chance. Whoever knows, maybe you start liking it.
Okay, thanks very much for those positive concluding words. Thanks very much to our guests for joining us and to you for listening into this episode. Follow us on Spotify and Apple Podcasts and check out the podcast homepage on the Cordis website. You can subscribe to make sure the hottest research in EU-funded science isn't passing you by. And you can find more information and project examples on the Cordis website, on the European Commission's Research and Innovation website, and in our online magazine, Horizon. We'll include the links in the show notes for this episode.